The purpose of this video is to discuss how to design program 3. So let's take a look at program 3. We have the instructions, a basic overview of the problem, and some data. So let's take a look at the instructions. It says we have an input file and we're going to print a formatted output result. So we have a laboratory test list of laboratory tests, and we have a single record containing patient name, patient ID, exam 1, exam 2, exam 3. That's the input. You're always looking for the input and the output. And the output's going to be, if they have an average exam score, it says positive. If it's if it's greater than 97%, you add the message risk, for high risk. If it's invalid data, you indicate that it's invalid. And this is the valid ranges for valid data. So the way to approach this is to look at all the inputs and all the outputs. Here we have an input file with a name, patient ID, and 3 exam scores. That's input file 1. Input file 2 is the same thing. Input file 3 is the same thing, and input file 4 is the same thing. They're all the same format. The difference is that the average of these is 75, which gives it a risk, a regular risk. This one has an exam score which is above the legitimate range, which means that it's invalid data. And it's supposed to print out invalid data when that happens. It does not print out any average because the average would be invalid. Here, let me just pop this down here so you can see. These are all basically the same thing. Oh God! These first 5 columns are always the same every time. And then input file 3, we have this high risk example, and 4 is a negative. The test comes negative. They're all zeros. It's less than 75, so it's negative. I think negative in exams, in hospital terminology is a good thing. Anyway, so we have to print this. This prints an average. This prints an average, but this one does not print an average. So the logic is a little bit different for this one. So basically, we have one form for the data coming in, but we have 4 different forms for the data going out. So the first thing we have to do is gather this data, and so let's go to structorizer, and let's start off the design, and we're going to call this program 3. I'll use 03 because then they sort in order. And the first thing we have to do is get the data. So we have input. We need to get patient name, I believe it was called. And the patient name variable does have to be patient name with a lowercase p and a capital N. Patient ID is the other one. So we're going to get an input of patient ID. Sorry about that. And we're going to need exam 1, exam 2, and exam 3. So same thing. We're just inserting the input statements. Okay, so now we have the data. We've received that from the input. Now the next thing we have to do is process the print. Now it looks like every single time it prints this exact line. So it prints it here, prints it here, prints it here, and prints it here. So it always prints that first. So the first thing we can do is just print that line of code. So here we'll do insert here, print. Uh-oh. Copy. There it is. So now we've got that print statement in there. So now every single time it gets the input file, the data from the input file, and then every single time it prints this line out. Now it looks like every single time it also prints out these lines. So we can also do a print statement for the column headers. So let's go to structorizer and do that. And these lines here too. Okay. Now, looks like the spaces did not get included in there. Anyway, so those are correct though. So then the next thing we have to do is we have to print this line in the proper format. So I guess we can say here we're definitely going to print these first 5 items. But then we have to figure out how to print these other 2 items. So let's print those. Let's go in here and do print. It's going to be patient name plus a space plus patient ID plus a space plus exam 1 plus a space plus exam 2 and exam 3. So there's our next print statement. So we have a new line character after these 3 lines, but not this one. So if we wanted to, we could put that in there. And then now here, what are we going to print? We have to check certain conditions. So the first thing we have to do is to check to see if we have valid data. Because we print the average out if there's valid data, but we don't print the average out if it's invalid data. So the first thing we have to do is to check to make sure that it's valid. We have to check that the patient ID is between 1111 and 9999, and we have to check that the exam is between 0 and 100. So how do we do that? We go in here and we do first thing we got to do is check the patient ID. And we say, first thing we're going to do is we're going to create a variable valid. And we are going to assume that it is valid. We assume that the data is valid. So now we'll add an if statement. So if, let's just say patient ID is less than 1111, or patient ID is greater than 9999. If either of those things are true, it's not valid. We could also say patient ID is greater than 1111 and patient ID is less than 9999. Less than or equal to, greater than or equal to. So this way we're saying if that's usually it's usually easier to do these logic statements when you use positive words. So if it is in fact within the proper range and that's true, then it stays valid. Otherwise, it's invalid. So here, if it is true, then we don't do anything. If it's not true, then we have valid gets false. It's no longer valid. Now the next thing we want to do is check another condition. If the patient, if exam 1 is within 100, is 0 to 100, and exam 2 is 0 to 100, and exam 3 is 0 to 100. So how do we do that? We say exam 1 is greater than 0, and exam 1 is less than or equal to 100. So it's actually exam 1 is greater than or equal to 0, and exam 1 is less than or equal to. If that's true, then it's valid. If it's not true, then it is not valid. So we say valid equals false here. Now I really want this to span the entire. I wonder if I can cut this. Oh man. Nope, I can't do it. How about, can I do this? I wonder if I can insert a line here. Put it at the very bottom. Nope. So let me just do this. I've got the patient names here. I'm checking the patient ID between 111 and 999 inclusive. If it's not in that range, then valid gets false, which means it's invalid. Then I created this kind of fake line in here, and I added another one, which is if the exam 1 is between 0 and 100. If it is, valid's true. If it's not, valid's false. And here I'll just be explicit about it. Valid is true. You don't have to put that in there because it's already set to be true. You know what? I'm going to put this up here and set it to be true. So here we print this, then we set valid to be true. If it's in the valid range, it stays true, and if it's not in the valid range, it goes false. Again, same with this one, and I'm going to do the same thing with this one. Copy, paste, paste, paste. I'm going to do the same thing with exam 2 and exam 3. So here I'm going to put exam 2 is less than or equal to 0. Sorry, greater than or equal to 0. And exam 2 is less than or equal to 100. And if that's true, then fine. If not, if it's false, then valid. Oh, man. This variable called valid, keep it in the same key. Valid gets false. What the heck's? Unless you hit. There we go. And so we have it for exam 1, have it for exam 2, and now we got to add it for exam 3. Okay, that was easy. Now I'm going to delete these unnecessary lines. So we set valid to be true. If the patient ID is okay, it stays true, otherwise it goes false. If the exam is good, it stays true, otherwise it goes false. Exam 1, exam 2, same thing. We'll just put valid equals. And then exam 3, same thing. Now, why would it have V and F? I think it's because of my language. Okay, so false. This one needs to be valid. It's false. Okay. And now we set the valid variable. Now I'm also going to create a variable called average. So this thing's going to be called average, and if it's valid, I'm going to compute the average. So so here I'm going to add a statement here. If valid, which means valid is true. We could say valid equals true, but it's the same thing as saying if valid. If it is valid, then I'm going to print the average, because that's the next thing I've got to print. See this? I've got to print that average. If it's not valid, though, I've got to print invalid data. So if it's not valid, I'm going to print invalid data. But if it's valid, I'm going to print average. Actually, I've got to compute the average first. I'm going to say average gets exam 1 plus exam 2 plus exam 3 divided by 3. And then I'm also going to print it. I compute the average, and I'm going to print the average. Print average. Oh man, I hate this. Hang on. There we go. You can move this around, but it's not easy. Okay, so now if it's valid data, I print the average. If not, I print invalid data. And then I also have to do some conditions. If it's valid data, I've got to print negative, positive, or positive with risk. So here I can add another if statement, and if it's if the average is less than 75, right? If the average is less than 75, what does it say here? If the average is less than 70, greater than 70, then it's positive. So it's less than or equal to 70, then it's going to be negative. So let's do that. So if it's less than or equal to 70, then I'm going to print negative. So that would be this case here. You print the average and it's negative. Now, if it's greater than 70, if it's greater than or equal to 97, then it's going to be positive with risk. So let's do that. So let's go back here and say if it's, so in this case, it's not less than 7 or equal to 70. It's 70 or greater. Here it's going to be if it's average is greater than or equal to 97. Right, so it's greater than, if the average is greater than or equal to 97, then add the message. It'll be positive risk in that case. So it's greater than or equal to 97, it'll be print positive / risk, and otherwise we print just positive. So that's how you can make a nice clean NS chart here. Now the very last thing we have to print after all this is done is just end of report. Done. So this right here is a nice clean structure chart for an NS chart for program 3. Printing this thing can be a problem because it's going to print out a small, it's going to fit it to the paper size. It can't print across 2 pages. It's not good for printing. That's why I want you to print it, I want you to just submit the file rather than print it out. But I'll print it in this case just to see what happens. So I hope that gives you an idea of how to design the program. The key is to be able to look at the input and check out to see that, you know, what the input is and how it affects the output. In this particular case, the input always is the same form, which is name, patient ID, exam, exam, exam. It's always the same form. The output just only depends on the whether it's invalid or valid data and whether the average is. So you just build a little conditional structure there, and boom, you're done. Hopefully this gives you an idea of how to do design. The next ones will be more complicated, but we'll get into some more details here regarding how to code this thing into Java later. By the way, it's probably not a bad idea to go File, Export, Code, and give yourself a head start coding this thing, program3.java. I just saved it. We'll do that in the next video.